So today we will learn about cache write. What it means that whenever we want to make some changes into the data which is being stored in the cache, or we need to update the content. So in the terms of computer, we say it as cache write. Now the another thing is that whenever we are making some changes, it means that we have to change it in the cache. Along with that, the changes have to be implemented on the main memory or the RAM itself. So there are two types. One is write through, one is write back. In write through, the whatever changes are being made in cache will be also implemented in the main memory itself in a simultaneous manner. For example, if there is something called x equals to 2, and in the main memory also x equals to 2 is stored. So whenever we are making some changes, like we change it to 3, so we'll also make the changes here as well at the same time. So what are the advantages? The advantage is, the main and prominent advantage is data consistency, which means that when I'm making the changes here and here as well, so it will be 3 and 3 at the same time. And the another disadvantage is that it will take a significant amount of time in order to update the data here in the cache in the main memory. Now there are two important formulas which we have to consider when we are performing a read operation. In that case, we are having two formulas. One is for simultaneous, one is for hierarchical access. In simultaneous, we'll multiply the hit ratio with the cache memory access time and the miss ratio along with the main memory access time. And for the simultaneous and for the hierarchical one, we'll multiply this hit ratio with the cache memory access time and the miss ratio with the sum of cache memory access time and main memory access time. But in the case of write operation, we have to consider the maximum out of these two, the cache memory access time and the main memory access time. Usually we know that the cache memory is faster and main memory is slower, so this is going to take higher amount of time. So the maximum of these two is usually the access time for the main memory. And in order to find the total average time or the overall average time, we will use this formula where we'll multiply the t average for read operation with the fraction of read, and the t average for write operation will multiply it with the fraction of write. There is a CPU which performs certain operations, certain number of operations, out of which 90% of them are read. So this fraction will turn out to be 90 by 100 or simply 9 by 10. So from this we could already interpret that 10% of them will be write operation and the fraction will be 10 by 100 or 1 by 10. We could simply use this and put it in this formula. One more terminology is the effective hit ratio. So in case of read, we are getting this thing. Whenever there is a hit, only cache is accessed. However, in case of miss, we have to go to the main memory. In case of write, we'll access both of in both the cases, whether it is hit or miss, we'll simultaneously write the or whatever updation is to be made is made on main memory and the cache memory at the same time. So for the calculation of effective hit ratio, we will use fraction of read and multiply it with the hit ratio for read. Now write back is an interesting part where whenever certain changes are being made in the cache, for example, there x is equal to 2, we have made some changes like 2 is converted into 3 or updated into 3. However, this thing will not reflect in the main memory at that point of time. So the question arises that how will this data be transferred to main memory? Otherwise there will be data inconsistency. Yes, there will be data inconsistency because this updation or this thing, the operation which has taken place and made the data different for this variable x. So for the next time when CPU will make a reference which is not present in the cache, so as a result it has to go to the main memory, fetch the block and bring it here, and in case the cache is full, it has to remove some blocks to free up space. So at this time it will send it back to here, and at this particular moment the main memory will receive the updated data for this variable. So one of the advantage is time saving, because we are not going to the main memory in order to update the variable data. We are only accessing the cache, so it is time saving. However, we have seen data inconsistency because here we will be having x equal to 2 only. However, here we have updated it to 3, but this updation is not reflecting here main memory. Now here also we are having two formulas for simultaneous and hierarchical. For read and write, both of them will be same. We'll use this for simultaneous and use this for hierarchical. Now there are two certain factors, like the write allocate and write no allocate. Write allocate means that whenever there is a write miss, the missed block is copied from cache, copied from main memory to cache. And in case of write no allocate, as the name suggests, that there is no such case of copying the data from main memory to cache. So in order to optimize the system, we use these two combinations. As we have seen, for write through, the data is simultaneously updated in cache memory as well as in the main memory. So there is no need for write allocate. That means we don't have to copy that block from main memory to cache memory. However, in case of write back, which means we will update the data in the cache memory but not in the main memory at that particular time. However, we'll update it when the block is being replaced. That's why we use write allocate as a combination along with write back. So these are the two combinations which we use together for better performance.